Okay, pre-cal, here goes. Quick quest review video. Given these zeros, let's find a polynomial function that passes through the x-intercept at these spots and also contains the point 640. So how do we do that? Well, first of all, what are the factors that are going to yield these zeros? So first of all, x equals 0 means that we just have the factor x. X equals -2 means we're just going to have x plus 2 as a factor. And then this last one, remember what we talked about in class. Let's find out what the factor is based on inverse operations. So if x equals 6 minus 2i, let's move the 6 over as x minus 6 equals -2i. Then from there, let's square both sides, which gives us x squared minus 12x plus 36 equals 4i squared. Now, of course, I squared equals -1, so 4i squared simply becomes -4. So when I add that 4 from the right back over to the left, I get my factor that yields that root, and that factor is x squared minus 12x plus 40. There's our factor. So we've got 3 factors, 2 linear factors and 1 quadratic factors, 1, 2, 3, 4, 1, 2, 3, 4, because remember, imaginary roots always come in pairs. So we've got all our factors. We're going to start multiplying them together. So call it f of x. F of x equals x times x plus 2 times x squared minus 12x plus 40. So we're going to carefully multiply these together. First, the x goes through, and then use the distributive property twice. Like I've said in class, I prefer to line up my like terms. Just checking my work. Okay. So we end up with x to the 4th minus 10x cubed plus 16x squared plus 80x. All right, so hopefully I did all that right. Checking one more time. Okay, so this is our function, but wait, we've still got to use this piece of information, which essentially means we need some integral constant value a that we're going to multiply through that's going to cause the function to pass through the point 640. So f of 2 equals 640. Well, let's plug that in right down here. 640 equals a times, plugging in the 2 everywhere we see an x. So 2 to the 4th is 16, and 2 to the 3rd is 8, so 10 times 8. X squared is 4, 16 times 4, and then 80 times 2. I'm going to bring in my handy dandy calculator here. So we are going to go straight across here. 16 minus 80 plus 64 plus 160 gives us 160, and 640 is equal to a times 160. Guess what, ladies and gentlemen? A is 4. A is 4. So what does this translate to in our answer? Remember, we were given these zeros, and I asked you to find a polynomial that contains these zeros and also passes through the point 640. So we've done that. We know our coefficient here, and probably the easiest way to multiply that coefficient a through just multiply it through right here, and I will put it in the box below. Our function is f of x equals 4x to the fourth, 4 times negative 10, negative 40, x to the third, 4 times 16 plus 64x squared, 4 times 80x plus 320x. There you go. There's the answer. Next problem. Find all the zeros. So we did one of these in class today, and this is the one where we need to think about P's and Q's, and if we're going to go after P's and Q's, then there's our Q. Q is equal to 1, and P is equal to 32. So if we were to list all our P's and Q's, and I'll do that right over here, it would be plus or minus all the factors of 32, which would be plus or minus 1, 2, 4, 8, 16, and 32. Those are all factors of 32. And if we were putting P over Q, Q equals 1, those would be our factors. So we're looking for one of those to be a rational root. Now, I've already got this plugged into the calculator, and we're going to graph this because we want to be able to look at the graph and discern what is a real root that we can then use to depress the polynomial. Because right now, we are at a 5th degree polynomial. So we're looking for 5 roots. So let's see what the graph looks like. Here's the graph, and check out what appears to be a cubic function. This is a cubic function passing through positive 2. What that means, and it doesn't bounce here, so it's not an even degreed multiplicity or an even multiplicity. It's an odd multiplicity, and if we really just focus on this piece of the graph, it's a cubic function. So what that means is we don't have a double root, we have a triple root at positive 2. So x equals positive 2, and that is not a double root, but a triple root. So what are we going to do with that too? We're going to depress the polynomial not once, not twice, but 3 times down with this root of 2 using synthetic division. So here goes. 5, 4, 3, 2, 1, none. Every power of x is there. So 1, negative 8, 28, negative 56, 64, and negative 32. And remember, we are expecting a 0 remainder. If we don't get a 0 remainder, then something's wrong, because we can see on the graph here that we have a triple root going on at positive 2. So here goes. Bring down the 1. 2 times 1 is 2. Negative 6. Negative 12. 16. 32. Negative 56 plus 32. 56 minus 32. That's 24. Negative 24. 2 times negative 24 is negative 48. 64 minus 48 is 16, and 2 times 16 is 32. There's our 0. Remember, triple root. Just like we saw in class, we can keep depressing down with that same repetitive root. Why? Because it's a factor that's occurring not twice this time, but 3 times. So keep going with the 2. 2 times 1, 2. Negative 4, negative 8, 8. 16, negative 8, negative 16. And just again, what are we expecting? We're expecting a remainder of 0. Depress it down again with the 2. Why? Because the 2 is the triple root. And again, we get a 0 remainder. So we went from a 5th degree polynomial now down to a 2nd degree polynomial. 1x squared minus 2x plus 4 equals 0, which is a simple quadratic equation to solve. So here goes. And it's also a good candidate for completing the square because there is a 1 up front and an even number in the middle. So we'll do it by completing the square. So x squared minus 2x plus a blank equals negative 4 plus blank. Half of 2 is 1. 1 squared is 1. Adding 1 to both sides. This left-hand side, we have forced the issue. It's a perfect square trinomial now. Factors of 1 that add up to 2, x minus 1, x minus 1. On the right, negative 4 plus 1 is negative 3. Solving for x by taking the square root of both sides. And then finally, add the 1. X equals 1 plus or minus I root 3. So we've got 2 as a triple root. So x minus 2, x minus 2, x minus 2, and then 2 more imaginary roots here. 1 plus or minus I root 3. Now, let me say it again one more time. What are we doing when we do the synthetic division? We are depressing the degree of the polynomial. That's the whole purpose of dividing, is we're taking it down from a 5th degree polynomial to a quadratic polynomial because we've got tools in the toolbox to solve quadratics. That's the whole purpose in doing this, in order to find all the zeros. There you go. Study hard.